Hi there, and welcome to this video on two-way tables. Today we're going to be considering two-way tables, which you might also hear being referred to as contingency tables. We would like to use a table to compare the number of girls and boys born in England and Wales each week. If I had this data then, I could create a two-way table to show it, with some of the data, i.e. girls or boys, along the top of the table, and whether we've got it in England or Wales going down the side. So I could assign girls, boys along the top. You'll notice I've left this first one blank, and it's because essentially it's like one of those multiplication tables. So that's like the crossover of the two information. Along here, we'd have where they're born, England or Wales. Now, there are two empty categories here, and this is because we always include totals on a two-way table as well. We're then able to complete the two-way table with numbers. Imagine I had these numbers then. This number here means that 335 baby boys were born in Wales in a week. I can use these two-way tables to find out a lot of information, but firstly, I'm going to complete the totals. So I want to know the number of girls in total that were born. So that would be the 741 in England plus the 285 baby girls born in Wales. That means last week we had 1,026 girls. Let's do the same for the boys. 529 in England and 335 in Wales. That's 864 boys. Now let's total the columns. So how many girls and boys were born in England? 741 plus 529. So that's 1,270 in England. How many in Wales then? 285 plus 335. That's 620. Now this total value here should be the same as whether you add these two values or these two values. So it's always a good idea to check that they both equal. If I add 1,270 to 620, I get 1,890. And if I do 1,026, add 864, I also get 1,890. So I know my totals have been worked out correctly. From these two-way tables then, it is possible to find probabilities of selecting something from the table. I.e., for the first question, what's the probability of picking a girl born in England? Well, in England, there were 741 girls born, out of a total of 1,890. What about picking a boy born in Wales? Well, there were 335 boys born in Wales, out of a total of 1,890. What about picking a baby born in Wales? So it can be a girl or a boy. Well, in total, there were 620 babies born in Wales, out of a total of 1,890. What's the probability of picking a girl then? Well, there were 1,026 girls out of 1,890. So we can calculate probabilities based on these two-way tables. You'll notice that I've done them as fractions, but it is possible to represent a probability as a decimal or a percentage also. I just find fractions work easier given the information it's already given as raw numbers in the table. What about this time? I've given you some of the totals, but actually some of the information within the table is also missing this time. Well, you can work backwards to fill in the gaps. For instance, I can find the number of girls born here because I know that in total there was 1,270. 529 of them were boys. So let's subtract them. That leaves me with 741 girls. I know that 376 of those girls were born late. So how many were early? Again, subtract them because you're working backwards. That means there's 365. Now I can find how many were early altogether. So add them. If you're finding totals, add. If you're working backwards, subtract. That means 572. And now I'm just missing the late boys. 207 were early and there was 529 altogether. So again, subtract this time because I'm working backwards. That leaves me with 322. There's a few ways to check that these are all correct, but fundamentally make sure that this column is the same as this row added. So 572 plus 698 equals 1,270. Perfect. And 741 plus 529 equals 1,270. Great. Now let's try some of these probabilities. I want to know picking a girl that's born early. So a girl that's born early is 365 out of 1,270. What about a boy that's born late? 322 out of 1,270. What about picking a late baby? There were 698 late babies out of 1,270. And what about picking a girl? There were 741 girls out of 1,270. Try this quick question then that's taken from a past paper GCSE question. Pause the video and when you're ready to go through the answers, press play. I'm just completing the two-way tables here. So remember, if you're finding totals, to add the columns or the rows. If you're working backwards, use a subtraction. So to find all the tea bags together, I'm adding 2, add 35, add 15. That's 52. I know that this column must add to 25. I've got 0 and 20 altogether, so I need a 5 there. This time, I haven't got sufficient information to add this total, but I can find the total here by working across the rows. 52 plus the 25 is 77, and I know the total overall needs to be 100, so there's 23 missing there. Now I can find this missing value from the fact that I've already got 35 and 20 in the row, and it all needs to add to 60. So that's a missing 5. Now I've got enough information to complete all the rest of the boxes. 5 add 5 is 10, plus a 13 gives me the 23. Adding along the rows then, that's 7. 15 add 5 add 13 is 33. And just checking, 7 add 60 add 33 does indeed give me 100. 3 marks there, not bad. Try this next question. Again, pause the video, but if you need longer, press play when you're ready for the answer. Okay, we have to read the question carefully this time because it's not actually given us any information in the table. It's all written here. 56 students were asked if they watched tennis yesterday. So 56 is my total for the entire table. 20 of the students are boys. So in total, there are 20 boys. 17 girls watched tennis. So watched tennis, 17 of them were girls. And 13 boys did not watch tennis. So 13 boys did not watch tennis. Now I've put the information I've been given in the question, it's the bare minimum to help me try and figure out the rest of the remaining numbers. Fill it in much like we did the same one. Next is an add-on question that's related to the two-way table you've just completed. It's one of those probability questions, those. One of my students is chosen at random from the table. Write down the probability that the student chosen is a boy. Well, there were 20 boys out of a total of 56 students. Here we've got 5 seconds to answer these questions, but if you need longer, pause the video and press play when you're ready for the answers. How many males chose cricket? I need to try and find this missing number here, so I'm going to look at the row. I know it should add to 44. 26 of them are female, so I'm just going to do 44 take away 26. That gives me 18 males. How many students studied French? This time I need to find the total for French. I know there were 7 males and 2 females, so I'm going to add them to make 9 students choosing French. This two-way table shows the hand students in a class write with, and whether they're a girl or a boy. What is the probability that a student chosen at random is a right-handed girl? There are 13 right-handed girls in the table out of a total of 29 students. So the probability is 13 over 29. Sometimes a two-way table question will just be presented to us as textual information. It won't actually give us the empty table to complete, so we have to draw that ourselves. A midwife asked 30 of her patients if they wanted a home, hospital, or water birth. So we have 3 categories to go along the top of my table: home, hospital, water. And not forgetting that the two-way table will also need a total column. Now let's see how they're separating her patients. She's done it by age, under 25s and over 25s. So let me write those categories in the rows of my column. And again, I need a total row. Now I've got the rough outline of my table, let's put the information in. I know that there's 30 patients that she asked. So my total for my whole table is 30. So the total column and the total row is 30. 8 of the patients are under 25. So the total of the under 25s is 8. 5 of the under 25s wanted a hospital. So 5 under 25s in the hospital column. 9 of the over 25s wanted a home birth. So 9 over 25s in the home column. 2 of the 5 patients who wanted a water birth. So I know the total water births was 5 and 2 of them are under 25. So there's 2 bits of information in that sentence there. Again, they've given me the bare minimum. Now I need to try and find all those missing values. If there's 8 people in total in the under 25s column, 2 in the water and 5 in the hospital, that means 1 wanted a home birth. Now I know that the total for home must be 10, 1 plus the 9. If there's 10 wanting a home birth, 5 wanting a water birth, and 30 in total, it means 15 must want a hospital birth. Now I can work to fill in these blanks. Now I can answer the additional question at the end. How many patients wanted a hospital birth? So the total for the hospital birth is 15. Try this question now. Pause the video and complete a two-way table for the information given. So, students are separated into which activities they do at lunchtime: art, music, or drama. So these are going to form my columns. And again, be sure to do a total column. They're separated by whether they're girls or boys. So these are going to form the rows of my table. And again, having a total row. Let's look at the information from the table then, from the question then. There are 100 students altogether. So my total row and total column will be 100. 31 students do art. So the total for art is 31, of which 16 are girls. So 16 girls do art. 25 students do music, of which 13 are girls. And there are 43 boys altogether. So let's fill in some of the blanks. Now I've filled those in, let's find the amount of girls that do drama. Answer these questions whether they're true or false. You need to total each row and each column in a two-way table. Yes, that one's true. You should always include a total column and total row in a two-way table. The question will always tell you that a two-way table is needed. Not necessarily. Sometimes they don't even include the table outline for us. We have to draw our own. The table structure will always be drawn in for you. Well, we've just seen that. It's not always the case. Probabilities are always given as decimal numbers. No, in fact, it's easier to write probabilities as a fraction from a two-way table. Thanks for watching your introduction to two-way tables. Now try some of the complementary resources that can be found within the RISE programme or on the Moodle page. Thanks for watching.